Hello. Check 1, 2. Hello. As usual. Hello again. It's me. Time for another Proc-Gen stream with Apparance. I'm Sam. Just opening up Unreal. Building in Unreal 5. Some space stations using procedural techniques and my Proc-Gen plugin Apparance. Let us see how we're doing. Okay. So that's the way it looks at the moment. We've been using modular asset pack from Fab. You can see a lot of the modules here. And so we started off with walls, getting them working nicely, a bit of variation with the seeds, and then we looked at floors, which started off fairly simple, and now we have a bit more variety on the floors. Let's change the seed and see what we end up with. Go something a bit different. Yeah, there you go. Yeah, but this week I want to look at doors because we've got a couple of pieces of space station. And turn off the ceiling so we can see them a bit more easily. And it would be nice if we were able to like connect them together and have doors appear and things like that. And there's various ways we can handle that, but a basic requirement is to have actual doors. It's possible to have doors. Now these are currently being built to a grid, and the asset pack is like a 1 meter unit grid, and the walls and the doors are going to will conform to that as well at the moment. It would be nice, we'll have a look at that maybe a bit today, is if I wanted to be able to position an adjacent piece or room in any position, have it make the doors all line up nicely, and then bits of wall adjust accordingly. Now, oops, that's broken. And that kind of has some implications for how these procedures are put together. At the moment, we are filling the space between the sort of along the wall with regular sized pieces, and that means we can only have whole sizes to the rooms. So as you can see, it jumps one whole piece at a time as we resize it. Now there are different ways we could handle it going to an arbitrary size, so I might look at that. We'll see how that goes with the door stuff. So we'll have a look at the doors first. At a later date, I'm going to probably revisit these floors and ceilings because there's still more things we can do with that to add variety. So I'll do that at another time. But I think we've done enough for now. We'll focus on something different. So doors, what do they look like? Let's go to the let's go to the parts page. So there's a couple of options. So we've dealt with the ceiling, we've dealt with the floor, we've got the walls here. There's some joiny cornery pieces. We're only using this one at the moment as a corner filler. We have this door here, which looks kind of like an exterior door. Maybe it's like a airlocky kind of door. And then there's this one which has the door frame. It's quite large. And then there's these door pieces here, which I think all right, connect those together. I think are designed to fit in this gap. So, and then you can, if you want, you could move them, open and shut them like that. So that's what we're working with. Yeah, this obviously fits in these rails. Oh, and I think that's fairly wide so that you can go to not quite open without getting too worried about bits disappearing. Maybe this bit moves as well, I don't know. There's only a limited amount of movement on that. Wonder if we could get it to go all the way. No, it's sort of there is the limit, and that one would be there. So that looks like a nice shut door. But we can actually parameterize that on the door if we wanted to at a later date. I'm not going to worry about the actual door itself for now. What I'm more interested in is this piece. This is like obviously a join between sections, which we probably that has some implications in that you don't want both rooms to have the door frame on. Unfortunately, it's not split, so we can't do it as two pieces. We could do this one. This might work back to back. Like so. And then it would be an access between rooms, but each room could be responsible for a piece. Or it could be an external one. I mean, this could be an external one too. It doesn't really matter. So how big is this piece? Let's have a look. So this is gate B. Or it's called a gate, which makes sense because it's quite wide. If we open up in here. 10 units wide. That's quite a lot. So we're going to be fairly limited on where we can use this. Obviously the room needs to be at least that wide. And it will be inserted into the wall procedure. So that's something we need to look at. Okay. So a couple of things we need to do to be able to use that. One is to set that up in the resource list, which we'll do. And then we can look at other things later. In fact, let's do that first. We'll set up that as a procedure to do the door, place the door, and then the actual door parts themselves as well. So we'll see how that all fits together. I think they all sit on the same origin and it's all in the right place. So we might have a play with that. Yeah, let's do that first. That'll get me warmed up back into the flow of things. And then we'll see how we get on from there. Right. So we've got a station resource list. So this is an Apparance asset type for managing how the procedures know about the assets that get placed. We've got some top level pieces here. Wall bottom, wall floor interface. Why are they? Okay, wall segment. Yeah. I'm going to put the door stuff under a folder called door. And for now we've just got unique pieces. We've got frame 10 because it's a particular size. Don't really need to worry about that too much. And that is it's this one. So I'll drop that in there. And we're also going to add door, what do you call it? Door panel. Panel main, let's call it that. Because that's the big part, we'll hook that up. I think that looks like, it's called R&L, but it doesn't really matter. Let's just use main and put out another one for panel side. They're called jam. Don't know. Let's call it side. Door panel side, and then that one will be that piece. Right, let's take that descriptor, and we'll need it in a minute. We'll start setting up some procedures. What we could do, might do it in here. No, we'll do it back in our main scene. Go back to that. So in a similar way, we had these test procedural objects for working on parts of things. We can do the same with the doors. We'll get the editor open, and then we can start putting some bits together. Let's have a floor, room, wall. I guess it's part of the wall stuff, so I'm going to do it in here. Door, main, door. So that's going to be our procedure for doing that. I'm just going to get it quickly set up so that we can see something happening. So resolve our door frame descriptor, and we'll place it down wherever. We'll sort that all out in a minute. That means we have a procedure we can up here for wall door. Okay, so obviously it's all squished. We'll come back to that in a minute. It's like 10 wide. No, X is the out. Let's leave that as that. 10 wide, 4 high. Don't know, something like that. We'll because we're gonna. We'll probably leave it. We'll leave it right. I think we'll do what we did before with the other things, where we've got the height we will define and the length we'll define by the bounds, but the thickness we will keep fixed to the original asset. So we've got logic for that. So I'm going to go grab that from piece. Where was it? All piece. Yeah. So here we go. Take the size, split it along the X, and that's the size of the actual piece. If we do the same thing here, and do that, we should end up with a. Did anything change? Yes. So actually a bit thicker than. Yeah, that's the full size. That's okay. So that's building it out from the back. Probably don't want that because it's double-sided. So maybe we want to use a shrink instead, which does it in both directions. Let's try that. Units in X, shrink to that amount, and then we'll have there. Look at that, that's better. So I think it just happens that the centerpiece is a unit, but now it won't make any difference if we resize our bounds because it's using the actual asset size. To know how tall are these? Not sure. Be about right. I could compare it to the actual asset, couldn't I? That one. If I drop one in. Okay. Okay, it's positioned so that it's flush with the floor. Okay, we might have to deal with that at some point. But it is also slightly taller. I'm guessing something like 4.5. Right. No. Oh well, we'll find out. Oh yeah, it might be. Yeah, there you go. It's 4.5. Okay, that's just so we can have it match. We'll deal with the floor alignment later when we actually start using it. What I might do is fit the door pieces in and have it parameterized on this procedure so we can have a nice funky door. Let's do that. To do that, here there are two parts. We've got the main panel and the side panel. So let's get those hooked up. No, we don't need that anymore, so we're using the shrink. And I'll just do it all loose in here. Or we do it differently. I think we'll probably just do it loose. Yeah, so this is the frame. And let us copy that, I think. We're going to want the main panel. We'll add in a minute. Again, thickness original. Don't know about the sizing. I guess we're going to have to cope with. Oh, hello. Hey, that's Cap. Thanks for the question. We are building space station rooms. At the moment, they look like this. And this. Oops, ceiling's on this, missing on this one. It's an asset pack that I found on Fab, and it's nice. It's not too overly complicated. It's got some nice designs on it, and I thought it would be good to use for procedurally building these sorts of spaces. And as you may have caught, they are, if you change the size, it'll rebuild accordingly. And there's also a seed value for randomizing the way it looks. So there's all sorts of different designs. We spent, let me turn that off. We spent quite a bit of time on the last couple of streams. If you only just joined, you'll have missed this bit. Yes, we spent quite a bit of time working on the floor and ceiling tiles and the way the layouts work. You can see some examples of the sort of logic here. And we had, again, if I turn on this, so you can actually get it to just automatically go through examples. So this is the same procedure that's used on the main room, but with a different seed each time. So you can see if I select one of these, the seed value is just increasing, and that causes it to rebuild. It's using my plugin called Apparance, and that's where this graph editor comes in, and it has all the logic. You build all the logic to create procedural constructs. So yeah, we spent a couple of streams doing the floor and ceiling logic and expanding on that, making it more varied. And the original one, we covered some, let me just get these doing their thing. The original streams, we set up the room and how to do the wall segments and the corners, and there's a bit of tidying up. And then what else did we do? Oh, there's a bit about the interactive editing. Got this smart editing system here where you can move things around, resize them just using by dragging handles. That was how that all works and how that was set up. Again, all functionality in the that comes with the plugin, but all the logic and this UI is all done procedurally. And today I'm looking at doors. And adding these. Do you mean where I'm going to use them? I don't know yet. This is just an exercise in showing how to build some of this stuff using the plugin. It's got a lot of other features and different ways you can work, but this is a good use case of working with modular kits that people have made and combining them together. We'll see where it goes. It's open-ended. I'm going to stream I'm just going to carry on streaming and see what we can get out of this asset pack. Ideally, I guess we're heading towards building a space station with lots of rooms and interesting things going on in them, stuff connecting between them. Might find some more asset packs for clutter and other interesting bits. And who knows, maybe even some exterior as well, so it could be like a big spaceship or something. We shall see. But yeah, suggestions and stuff is welcome as well. But today we're looking at doors. Not specifically for any particular game, but what I'm planning on doing is I'll share the project on GitHub at some point. And then if you wanted to muck around with it or build something from it, then you can. But you could make some sort of game. I'm a long-time game dev, been working on lots of games. This is my thing now, is building procedural middleware and procedural tooling. But yeah, this is the door that comes with the kit. And I'm just looking at the actual door itself, getting that hooked up so we can see how that's going to work. Right. So we've got this procedure here for the door. As you can see, this is the actual door output. So we've found the asset, we've placed it, but we also sized made the thickness match the original asset. At the moment, the size that way and vertically is specified as a parameter. We might need to fix that, make it fixed, or account for any size changes. We'll see. So I'm just going to add in this door piece and we'll see where we're at. So if I bring in, we're going to have 3 pieces. Let's put 4 in case we need an extra one. So I'm just going to hook up that. Okay, so that has placed. If we unplug that, so it's got the door panel, but it's placed it full size, which we don't want. What I think we need to do is use its size completely. So I'm going to change the way this works. We can adjust for that shortly. If I get the original size of the asset, that's now a vector of its size, and use a resize. What we'll get is the units Z. So the unit that's now the original asset size, because we're just taking that the asset bounds and using that to define where it gets placed. That is I also put it at the bottom edge because we want it along the bottom or somewhere like that. There's going to be some fiddling around needed in a minute to get it all to line up, but we can play with that. So I put the outside back in. And now we have the problem where it's not going to be sized accordingly. What we might be worth doing is have some sort of scaling factor. I mean, it's unlikely we'll resize it much, but I think with what I have in mind, later we might need to have it generally resizable. For example, if it might need a slight squeeze or squash to fit into a space. So if the door in the middle doesn't do that, then you'll start getting gaps and it will look odd. So what I need to do is work out how much it was scaled up or down by there and how much there, and apply that to the door in the center as well. So let's do that. We might also need to apply it to the vertical offset to get it to sit on the same line here, but we'll deal with that. So let's have a look if we can get that to fit. So what we've got, let me just make a bit more space. We're working on this. I'll try and keep it not too hidden behind me. So this is the original bounds, and this frame is the size we've ended up placing it at. So, and that's using some of this information coming in here. So if I find the dimension of this result, it's basically the difference between these two sets of dimensions is the scaling factors in the X and the Y. What I'm going to have to do there, or what I will do there is, so this is the after, and this is the before. Oops, typing. So if we divide the after by the 4, so we're looking at the X is the thickness. We want the Y, which is the horizontal. That's our horizontal scale factor, and the Z is the vertical. Yeah, that's that hooked up. That's the vertical scale. So we can use that for the door parts. Move everything over a little bit, because if we this size here, we're taking the original asset size. We want to apply this horizontal and vertical scale. Is there an easiest way of doing that? Is probably breaking this out, maybe. And No, I'm going to make a little utility for that. Let's do that here. Let's call it, no, let's call it vector multi-scale. Just a little utility which I'm going to create here to break out scale and recombine. So we've got our vector in, our vector out. We're going to scale the x by some amount. We're going to scale the y by another amount. And then the z by a third amount. So these are what I will do is set their defaults to be 1. And that should be all we need to do that. That can be called out. Let's call it out. Right, now if we do... yeah, we don't need that one. If we use this here, this value, move all these around a bit. So now the door, we can scale. Oh, that's the x. We're going to leave the x as 1 because we're not changing that. Yeah, so we need to be able to scale the horizontal and the vertical. So if I hook up the horizontal scale, is that one, and the vertical scale, which is that one, that should, as we scale, it should scale proportionally. Nice. So the only issue now is it's just not quite in the right place. So it needs to go up slightly. Again, we can use the scaling factors to adjust accordingly. If we can work out what this size is, I don't know, maybe it's like half. What does it look like? It looks like we can tell from here probably. Oh, hang on, that's not the original size. Is that original height? Is that so? I reckon that's going to be a quarter. I'm going to lift it by a quarter. It might not be. There's a half. Yeah. Let's try lifting out by a quarter and then see what happens. So if we're going to reposition it vertically, we can use the offset. Yeah. So that's the scaling part to make it fit be the right size. We want to move it up a bit by some units. We only need it in one axis, so we'll do the. We'll just make a little vector out of that. So we're going to feed it through here. Get that in the right so we can see it. So that means we can do an offset, which we will do in a sec. Work out how much in a minute. It's going to be some hard-coded value that goes with this asset, so it's going to be a number, but it's going to need to be modified by this vertical scale here. So we're just simply going to multiply that. Let's say our number is half. Vertical scale is that, and then that's the amount we want to lift it by. Donk. Okay, it's not a half. Oh no, I said it was quarter, didn't I? So we could manually adjust here, or I could put it in and guess, and then inspect. Ooh, that looks like that'll be good. I'm going to go with that. But because the offset is scaled, in theory, yes, it adjusts at the bottom correctly as the whole thing is scaled. So that's good. And the initial position is going to be over to the right slightly. So let's have a look at that. Similar thing, need to offset it. A horizontal scale, the Y. Now this one might not be as obvious, so let's have a look. Ooh, I wonder if it is exactly a quarter. No, that doesn't help. Sorry, can't see from there. Might just go with that quarter. It seems to line up nicely. Okay, good. So we can do a similar thing with the other piece. We could have generalized this in a sub-procedure, but I'm going to just repeat it for now. Yeah. What we can also do, yeah, So because we've got the X value, oh no, not the X value, silly me. I do, instead of plugging in a quarter, if I plug in a quarter there, this value now becomes our door open offset, which maybe the maximum is what, somewhere there? Yeah, we'll ignore the fact that it sticks out. 3.5, so if I do that, we can now open and shut the door. I mean, this wouldn't be used for animating the door in the game necessarily, because you'd be rebuilding all the geometry placement, but it's a good way of giving artists control over the sort of initial state, or maybe just it's a fixed state. Maybe it's stuck, half closed, maybe it's fully open, maybe it's a fully shut door. But it means that as you're building, you can place these down and decide what it's going to look like. Might go for a bit more open than that. Let's go for 4. Yeah, let's go with 4. Well, out of 4. Yeah, that gives us good. Oh, that's good because that's about the same as this. That gives it good clearance. Okay, nice. Right, let's shut that and work on the other side, which is going to be. So we're going to need to do the same stuff here, and we're going to need to offset it and place it. So it's, well, let's just duplicate all of that down here and see where we end up. So instead of main, we are side, I believe. We don't want to offset it 0.25. What do we want to offset it? I don't know. Let's go minus 0.75. I don't know. We haven't. Let's see if we. Oh, I haven't hooked it up yet. Get that out there. Okay, so that's appeared in the middle there. It's going to be something more like -1. No. -2. Ooh, get in there. We can fiddle with that. I don't think it's going to matter too much. We get it. Don't get it fully accurate. Yeah, something like that. 2 point something. Yeah, I wonder what that's going to be then. 2 point. Maybe it's 2. Nope. 0.1. 0.15. 0.2. No. 175. No. Maybe it is 1.5. No, I don't think it is. That'll do. A gap. Yes, it's going to leak. Can't have a leak. Let's go with 2.16. I don't know if that's sensible to do it quite that way. So the reason this is imprecise is we are placing them by their bounds, whereas the actual assets are designed to be placed by their pivot. If we placed all the pivots in the right place, they'd all line up, which we could do. There are what did I call it? Frame place. So this is used for placing an asset based on its frame. I mean, that's got a scaling factor as well. Sorry, based on its pivot. This has got scaling factor as well, but I'm going to stick with this for a minute. We do have the. It should still, yeah, it all still does the scaling properly. So we'll keep that. But what we might do is, what would be quite good. Okay, you notice how I said this was 0 to 4 to open and shut the door. What if we parameterize this to be 0 to 1 is open to closed, or one way around or the other? Yeah, we could do that. Oh, I haven't got a remap. I'll just do it explicitly. So let's do that. Let's have some value multiplied by 4 to drive the open and close. Amount the door is open. Okay, we can actually set this to be a specific range, and that means here we have open 0 to 1. What we can also do is have this move. It might be nice so it matches and sits back slightly from that position. So we could decide where that is by, yeah, I think it's going to be, yeah, it's going to be negative, isn't it? So we'll need to go flip back by a certain amount, maybe to there. Does that match that? Close. Let's go with a little bit less. That. Let's go with that. Let's go with 0.25. So similarly, if we multiply here by minus 0.25 and plug that in there, we should get the nice effect that our door now opens like this. Yeah, does that shut properly? Yeah. Cool. Turn it around a bit so it's in the light. Better. Okay, so we've got a nice door. We can have it open and shut. And smart. Very pleased with that sort of thing. I mean, you'd probably want, for the actual, if this was a game and you were running around and you want to click on the door to open it, you'd have in your blueprint you'd run some of this stuff, and these would be like sub actors instead. But for level layout and playing with it and getting an idea of how it all would work, it's going to be fine. So let's do that. Okay, we have a door. Maybe the default is open, don't know. Maybe the default is partially open. Do it like that. Okay, what are we doing with this door? So this door, let's go back to here. This door we're going to want in the wall somewhere. Obviously that's not going to look very nice if we do it like this. It seems like it might line up with the floor already. Okay, that's good. And it's going to need to be, alright, the height's wrong at the moment. Ooh, that's quite big. Why is that so big? Let's have a look. I wonder if, so is this being built to the height given? Not quite. Maybe we're not building everything the right height. So if the room was 4.5, the corners seem to like that, but the other pieces don't. So that might be the case. Does this mean our wall, these are all squashed? I don't think they are. They might be. It's not quite square. We've got any square features we can check. Not really. That's the door. No, I don't think they're square. Well, let's drop some assets in and measure them in a minute. Let's go back to the. Let's have a look at the asset pack. So in here, I put these pieces together by hand and got that. How does that compare to the? Oh, interesting. So if we line that up about, no, not quite. It would be, go with 5 there. So if it's there, then the floor lines up. Yeah, it does. Then the top also lines up although it sticks out a bit there. But why that is, that lines up. I might not have it positioned properly. That's interesting. So these these panels should come to the same height as that. Might need to make some adjustment for that, unless I'm putting them together wrong. So we've got this piece on top, that piece there, and that piece there. I might have hard coded that. I don't know. I'll have to have a look. How are we doing? Cool. So it looks like the whole thing. If we look at this asset here, nope, that one. That says 400 by 25 by 200. No, that's a window. Gate, here we go. Oh, 1050. That's not exactly 10 units. That's a bit weird. All right, we're going with 10. By 150 thickness, that's fine. We're just using that directly. 450 high. It is 4.5 units high. So we might be building the wall wrong. We have to revisit that to fix it. That's probably the first thing to do. Let me go back to our map. Yeah. No, I don't want to move those. Yeah, so this piece being 4.5 and this wall being 4.5, these bits don't come to that height. Let us work out why. Because in theory, it would all nicely line up then, because they sit on the floor here. So let's try that. I'll leave that there. We can use that as a reference while I fiddle with the procedures. So this wall procedure, if we dig into that, well, let's just start at the right. So this is the main. This is the main room procedure. We're splitting the space up. The sort of 9-slice utility. We've got the 4 walls. We've got 4 corners, and then we've got the floor and ceiling filler. No, we haven't. Yes, we have. Oh yeah, that turns out the other way for the ceiling, so I'll label that one. Ceiling. And we know that because it's got it ticked on there, look. But that's just the visuals, so that's not the actual, doesn't define it as being the ceiling, it's just what it looks like. So, what was I saying? Walls. We need to look at these walls. So this is the wall row. It uses the... Let me double check a minute. So vertically, the size snapping, the Z is taken directly. So we should... Yeah, we know that. Oh, so we know these coming out the right height because the corners do. So it must be something we're doing in here that causes it not to be. We're splitting it in Y because that's along the wall. Each section is being placed, and then we move along. Okay, in a section. Split 1, split 2, split 1. So we've hard coded the amount it's splitting. So there's some couple of choices here. We could support arbitrary scaling like we did with the door, which might be an idea. But that probably needs to come from the very top level a bit because the floor thickness would need to be adjusted as well. I mean, we could do that. I think we'll just fix this for now. So this 2 is 4. So which piece is wrong? That's the question. We're half a unit short. I would guess... Well, we can check the assets, of course. That might be the simplest thing to do. Let's have a look. So that bottom piece, that is 125. Well, there's a quarter missing. And the top piece is 125 as well. The wall, 2. So these 2 pieces are the wrong size. So we're squashing these slightly. And those 2 0.25s will give us the extra we need. So if we go back in here, instead of 1, we do 125. Ooh, there you go, that's given us a bit. And on this one, instead of 1, 125. Look at that. That's better. The door now fits. We can see the floor would line up. It's Z fighting. And we've also gained a bit of height. Makes it look a little less squashed. Yeah, and all these panels face inward a bit more than they were Well, that's an improvement. Plus it means the door's going to work properly. Okay. So we're going to have a door come in somewhere. That's the next bit. Okay. Good so far. Right. So let's talk about how we specify where the doors are, or how the walls do doors. So I think these, because this door is going to look best when it's 10 units long, and 10 is not a multiple of 4, it's going to be a bit of a pain to fit it into one of these walls. So at the moment they're always a multiple of these panel sizes, which is 4. Oh yeah, ignoring the plus the 1 on either end. Maybe that'll make a difference, I don't know. So it means that we can't just slot in or replace some wall panels with door. So we have a couple of choices. Either we could squish the door to 8. That might be a bit much. You can have a look at that actually. What does that look like? I mean, it kind of works. A bit squished. Yeah, that's supposed to be round. That's not going to work. Let's go back with 10. Yeah, that looks much nicer. So there are round features and square features that really shouldn't be squished. We are going to have to use, it's going to have to be 10. So for a given wall, which is a multiple of 4, that's not going to work. So what we might need to do is make the walls a bit more powerful. So instead of rounding to the nearest multiple of 4 and just filling that, what we're going to have to do for the walls is have it work out the best way to adjust to any particular size we want. So that could be that we could do it so it goes to a unit size, whole unit sizes, and we've used like pillars and other interesting pieces to add in and make it more interesting. Or, well, we probably want to do that anyway. Or we actually have it squash and stretch to fit an arbitrary size. That'll give us more control over laying out the rooms. You'll get slight squashes and stretches here and there, but that's not going to be as noticeable given that we've got like unit pieces we can fit in as well. So what I might try and do is, because we're going to be putting a door in the wall, and that'll leave 2 pieces of wall either side could be an arbitrary size. That means this capability of having them at any size is going to be really useful. And it also means we can position the wall at any position the door anywhere along the wall we want, which will help for aligning rooms that have been hand placed. Okay. So the next step, make the walls more powerful. We'll do that, I think, and then we'll see if we can get a door in a wall. Got a bit of a torrent of rain going on here, so it might be a little noisy. So first steps. Let's get the wall procedure out on its own and start fiddling with it and see what it looks like. We did have originally, but much like these ones here, I'll probably just plonk some along the side here, and we can play with them. So we can just stick a that's where's it gone? Wall row, maybe. 4.5, 20. So 20 fits. Let's do 18. Yeah, it doesn't. So here's what sort of situation we've got. We've got a particular space we want to fill, and it won't fill it because it only does multiples of 4. So there's different ways to deal with that. I think what we've covered a little bit of this sort of logic on some of the here, where when we're filling a space, we've decided how to fill it but keep it centered. So these side rails here, they're a random sequence, but they're mirrored. And then if it's an odd number of tiles, it puts an extra one in the middle, so we can see. So there's now, you can see it adding a little extra tile in here, and then using 2 mirrored sequences either side. So a similar idea to that, we can, on the wall, we could work out how many like unit pieces we need to put in to make it some multiple of 4 still, and that would fix it. Because there's a multiple of 4, we might need 0, 1, 2, or 3. So we'll have a look at what assets we've got for that. We know we've got these corner pillars, which are a single unit, I think. So we could just have those. And it could be that if it needs 1, it puts it in the middle. If it needs 2, it puts them either end. If it needs 3, it puts one in the middle and one either end, and then anything left is done as 2s. So that would work. Might be a good starting point. Let me just see what other assets there are, because I know there's kind of bulkheady pieces that, again, it would be interesting to insert that we could use. We could do that. And that gets us to some unit multiple, which is close to arbitrary. And then maybe if it's some somewhere in between integer values, it just does the scaling to fit. But we can deal with that later. I think going to this unit grid is probably a great first step, so we'll do that. Let's save that and have a look at the actual pieces again. Yeah, so there's these pieces here that I was interested in. There's a 2. Is that a 2? No. Hang on, let's see where that is. How big is that? That's odd. That's a weird. Oh, I've stuck it below the grid. For some reason, this floor is not on the grid. I wonder if I can move everything up to be on the grid. Not quite. A bit more. Oh yeah, that's on the grid, I think. Although we can't see it. So let's just move it all down ever so slightly. There, I'll do. Close enough for measurements, we'll do that. Right, so this piece, I put it here. So that's a 4. Oh, okay. So that's a 4. What are these then? Oh. Oh, hang on. This is a half-size grid. That's a 2. Yeah. So that's 2 units, I think. And this is 1 unit. Yeah. Let's check that. Yes. And this pillar we used before. Yeah. So you can see that's a 1 by 1. That's a something by 2. Some arbitrary number. Yeah, so we could. I mean, those do complicate things because they stick into the room. Might not use those right now. That one equally sticks into the room. That's an exercise for another day. Let's just use these pillars, these single pillars, because they will fit into the. Oh, hang on. How thick is the wall? Another factor. So we need to come into this distance here. Actually, let me move this down to the grid. So we've got yeah, 1.5, 2.5. I mean, is that what that is? Nearly. Good scale. We could certainly put one of these into the wall. Oh no, why is that not at all the same size? Oh, I see. It's 2.5. Those. Yeah. Because if we are inserting extra sections, they need to fill out to this level here. Ooh, it's getting trickier. Getting trickier. I guess is what this piece is for. Hang on, let me just bring one of these up. Sorry for the lots of thinking out loud going on. Hang on, let me just do this. Cool. Yeah, lots of thinking out loud. There's a lot of thought processes involved in building these sorts of things. I mean, that would produce an interesting inset. I'm not quite sure where this piece is intended to be used. Again, we could look at the sample map. It does end up being quite a chunky piece. It does stick in a lot. Having said that, we could... which way is it going to be? That way. Yeah, we could scale it so that it fits our layout better. It would just have some interesting sticking into the room type effects going on. In fact, that does fit quite well like that. That could be our spacing piece. Maybe we should use that. Because this corner pillar isn't going to work. Oh, actually it would work if it was stretched, scaled up to fit in here. And that's what we did in the... Because this is part of the wall. The floor starts here. So let's have a look at this piece. And see if we can use that. So that's column A2. Let's add that into the assets. Where would that be? So corners, we've got column B. It's not a corner. It is a wall spacer. Let's call it that. So let's add... yeah, let's call it that. And it is one of these. This, no, not the wide one. Not the column. It's column A, isn't it? Do that. We might use column B as well. Let's have a look at our map. So in here, did we? Oh, we did. We sized it, scaled it up to fit that wall thickness. So we could use that as a spacer as well. It would be squished sideways slightly. I think that would work. Means you get two of them at the end. Let's go with our new curved one that matches. Ooh, interesting. Oh no, it's squashed, that's why. That needs to be 1.5 or 1.25? 1.25. That match? Is that what we're doing? Did we decide to chop 1.25 off? Let's have a look at the room. 1.25. Okay, yeah, that's the corner size. So yeah, that's what we're going to do. We are going to insert those columns. So the logic we'll need. Hi Z positive. Thank you very much. I hope you're having a good day as well. So this wall, we're going to, in order to fill out a non-multiple of 4, we're going to go to multiples of 1, so unit grid, which means we need to work out how short of that full length we are going to be. So the remainder of dividing by 4, I think. If it's 0, we don't have to do anything. We just put in the 4 panels, multiples of 4. If it's if there's 1 left over, we'll put it in the middle and then do 2 multiple panels of 4. And if there's 2 left over, we'll put them either end for now and then do normal in the middle. And if it's 3 left over, we'll do center and ends. And that'll allow us to do walls of any unit length. We do need to cope with the case where, well, we might need to cope with the case where we're just trying to fill a small space, like a 1 or a 2 or a 3. Those should all work. It just won't. It'll just end up with no space to put any other 4 panels. So let's go ahead with that. So this is wall row. Have we got just a wall? Do we have that? Why do we not have that? So it's called row here. Well, the row is the filling. Yeah, there's row. more like row 4, isn't it? Multiples of 4. So let's rename it. It's row 4. So it's row of 4 unit wall pieces. So we'll keep that as a sub procedure. It's useful. We will be using it. But if we do a actually, that's not the best description. Row of wall pieces multiple of 4. Hang on. 4 unit grid. Let's call it that. And then we want another one, which is, I'm just going to call it row. So it kind of replaces the other one. This is a row of wall pieces 1 unit grid. So this is this will be the new procedure that has the capability to fill in up to the granularity we want. And if we just for now stick this in here and then switch this over to use that instead, that one. It'll look the same, obviously, it's the same procedure, but now as we add the logic, we can see the changes happening. So we had the thing before where we worked out how many tiles it was across, unit tiles, so we could actually just use that, which is tile count, so we'll use that. We're only working, which way around is it? We want the Y. So this is built in, X is facing us, Y is along the wall, so we want the H for whatever reason. So this H value, H is tiles along wall. So that value, and we're going to do some logic. We are going to find out if there's anything left over from dividing by 4, because that's what we need. And we need the ability to be able to put a centerpiece in and put end pieces in, or both. So we'll build the logic to allow for that. And they're going to be units. We can probably hard code that, that's fine. We did a similar thing on the floor logic. Let me see if I can find that. Floor. Edge symmetrical. Oh yeah. But here we only needed to know whether it was odd or even, because we needed to put in a centerpiece. But we use that to switch the width of that piece and enable whether it places anything. So we could do a similar thing. And maybe if we always do that, and even if there's no remainder and it's all 4 pieces, it'll still do it as 2s. Right? No, because of it's a single one. It doesn't want to do that. Let's work it out in a minute. Let's work it out in the logic. Right. Let's go and have a think about this in turn. What should we do first? Probably the ends. So if there's 2 or 3, if it's greater than equal to 2, we're going to want to put 2 end pieces in and then all in the middle. So let's do that first. So in this situation, we're going to select something slightly different. We'll fall back to full row. So that means, okay, at the moment our size is 18. If we do 17, yeah, so 17, that only has 1 remainder, or 16 has no remainder. So they still use the original path. As soon as we get to 2 remainder, it'll go to our new logic, which doesn't do anything yet. What we need to do is split a unit off the either end for our inserts, faces, whatever you want to call them. and then we can place the boards in the middle. So if we use the shrink is the one here, take the frame, we'll shrink it by 1 unit in Y. So this is not, by setting this to true, it'll just, our 1 will be the end pieces. With it as false, it will be 1 in the middle. We don't want that. We're going to have another row of 4, which we will have coming in the middle. Because having chopped those off the ends, there will be a multiple of 4 in the middle. Or we might still, if there's 3 remainder, we'll still have another one, but we're going to deal with that in a minute. So that we're going to be merging these 3 things together. So let's have a merge for that. And initially it's just that thing. We'll stick that in there. Right. So now our center, we've got with our 2 spaces either end. We need to do that. What we will need a. We've got a corner. Let's do a spacer. Single unit wall insert. Let's call it spacer. Yeah. It's going to be very similar to corner. The corner is original. No, it's not going to be very similar to corner. It's going to be more like piece. Yeah, let's just resolve and place for now and see what happens. We'll deal with the size in a minute. No, where has it gone? Wall spacer. So if we where is it? It was this one. It's just called station wall spacer. Grab that. Place that wherever. Okay, let's see how that looks when we hook it up. Right, so we need spacer here. And we have one the other side, one the other end, spacer here. So a couple of things going on. It's the wrong way around. Although it might be the right size because I think it's using. No, I think. Oh, actually, that's interesting. Let's just go with that for now. But we need to reorient it. And I think, given that the row is, when you pass in this row here, it comes out correct. These are the same, going to be the same orientation, so these should come out correct. So we need to reorient in here. We'll do that with one of these. In Z, nope. Other way, there we go. So that's given us that. I think that looks fine. Nice. Let's go with that. And then if we have 17, we have 1 missing. And if we have 19, we still have 1 missing. So this is in both cases we need to use slightly different logic, which is the one that inserts one in the middle. That might be a little tricky to do in general, but let's have a look. Let's have a look. So okay. We're going to need to do it here if there is 1 left over, or here there is 2 left over. It would be handy if we could, because it's exactly the same logic, we should have that as a sub procedure. Let us do, what would we call that? Because it's fairly specific, bit of functionality that we only just need to use twice here. It's row 4, but with a center piece. Let us call it something funky as well. I'll add a procedure here. Let's call it row 4 plus. Is that right? Yeah. No. Yeah, I'm just going to call it that. It's not particularly good name, but it just, we can describe it. It's a wall of 4 unit panels with a single spacer in the center. That's what it is, and that's what it does. Let's make that. We are going to shrink our frame. We're recreating this functionality, so we will need this. We'll shrink the frame by 1 in Y units. We will put a spacer there. We will merge these pieces together. We will put 2 wall bits like so. I might make that symmetrical. How do we do that? Can't. Let's not have them the same though, so let's have that. There's a different seed for the other half. Okay, I reckon that's what we need. So if this is 1, I'll just copy this for convenience. Basically, if we've got 1 left over, we need to use the new plus procedure. So, and if not, we'll go back default to the normal one. Oh, we're on the extra one. Let me go this back to 17. Okay, that's not what we expected to happen. Ha! Huh? 16 is that. 17 has 1 left over. What the hell is it doing there? Row 4 plus. Oh. Shrink to 1. So that we have a 1 in the middle and then walls either side. There we go. That works. Okay. So we now need to finish off the other one, which is here. We need the same logic as this, but if it's 3. So we could just copy that, I think. Just copy that to here. If that's a 3, we want plus, otherwise we want the 4. And now 18, 19. Oh, so close. What happened there? 20 does that, 19 does that. What happened there? Oh, need to hook it up to the center as well. There we go. Phew. There we go. So that's the one where there's 3 bits left over. That's the one where there's 2 bits left over. That's where there's 1, and that's where there's none. What that means is we can. It doesn't deal with the non-whole numbers, but that's fine. How's this working? I suppose another test is how does it deal with the small values? Let's make. So 8 will be 2 4 panels. 7. 7. That's interesting. we can't put that, we can't split it like that because we end up with 3s, no, 2s. 2s, eh? Well, we have a chunky piece we could put in for a 2, or it would have to be offset with two of these on one side and one on the other. That's 6. 6 works. That's a 4 plus 2 2s. 5. Ugh, 5 doesn't work either. 4 obviously works. 3. Yay. 2, 1. So they work. We've got a couple of cases to deal with. 5. 5 and 7. 5 and 7. I reckon if we had the 4 panel wall, put in a 2 piece, if it was only too long, then that would work. We should do that. So it kind of breaks the logic slightly. Let's put in the so that's wall spacer, which is 1. Let's put in wall spacer 2, which I think is that one. I wonder. I think maybe I should fix. So before we fix some of these orientation problems here, which is probably better than fixing it with that reorient that I added. Let's do that quickly while I'm thinking about it. So in the spacer we reoriented. If I undo that and fix it on the actual asset, it would be better to do that. Spacer. Fix placement, left, right, back, forward, other. Oh no, it's rotation, default rotation. There you go. Rotate it there. I think this one looks like it might be already be the right way around. Oops. Yeah, that's rotated. That isn't. So let's see if that works. So that's our spacer 2, which we're going to put in row 4. So if it's, it only places one if it's big enough, but we can check to see if it's greater than 1.99. What we're going to do is, interesting. Yeah, we see if we can do this. We want to place a smaller section, which I'm going to. Oh, it's a spacer, so let's do another spacer. Sorry, thinking out loud again. Spacer. A double width spacer. Do that. And resolve and place that. Leave it like that. Where's it gone? Row 4. Spacer 2. Hang on. Okay, if it's greater than 2, we want to use the bigger stuff. Less than 2, we want to use the spacer there. That's interesting. So it should be putting in row 4 here. Or is it? And the first decision here is if there's room for a 2, it'll use a 2. Hang on, let me diagnose this. No. Okay, so it is putting them in, just not happy. Why is it not happy? I don't know. Oh no. Greater than 2.01. There we go. So 2 or less-ish, it will put this funky piece in, which I think we can probably get away with. Makes for an interesting wall. Yeah, let's go with that. 6, 5. Brilliant. 4, 3, 2, 1. 3, 4, 5, 6, 7, 8, 9, 10, 11. Look at that. That's what we want. Now our walls are much more flexible here. So where currently we limit it to a multiple of 4 minus the edges, we should now be able to just do it to a multiple of 1. Where am I doing that? Size snapping. Step 4. Let's change this to 1. See what happens. Okay. Oh, got a piece. I got 1, interestingly. Let's see what we get if we do some smart editing. Oh, it's not quite working. I think we need to have a look at why. Oh, we're not using the new. We're not using the new wall. Wait a minute. Ah, panic. All right, let me just get one that's broken and we can test it. That's why we're only getting that odd bit at the end. Let me go and fix that. So we're using row 4 here. What we actually need is the new one, which is called row. So I need to hook all these up instead. I'm just going to pull all these connections across. No, that's not what I wanted to do. And that one, and that one. Let's do this. West wall. Let's do the next one. And across those connections. West wall, east wall. South wall. And north wall. Okay. Aha. That's better. Now we've got these symmetrical pieces. Let's try that again. Oh yes, look at, oh, interesting. How are we getting the 1s and the 2s? There's still something funky going on. That going on there. Oh, is that oh, it's a 6. We've got a 6. Oh, that's something we didn't test. Or did we? What size is that then? Ah, 13. Okay. 13 does that as well. Oh, because the wall supports, because this 4 now supports multiples of 2, we get this effect. Well, we'll go with that for now. Not symmetrical, unfortunately, but it is interesting. So, and it doesn't break. We'll always get the full wall filled in. So that's good. I wonder if that. I mean, another solution for this is 2 of these single pieces, or the ability to mirror the content. Anyway, I think we'll do a quick test to get the door in the wall, and then I'm going to call it a day. Let's do that. So let's turn off hello. Where's he gone? Right. Got a wall. I'm going to just do a procedure with a wall and a door in it for now, and then we can play with that. Am I going to do that? Yeah. So many possibilities. I'm going to have. Let's for now assume that a wall can have 1 door in it, and it can be positioned any unit position along the wall. So let's do that. I'm going to hack that into this wall procedure. Let's make this a bit bigger so we've got a bit more space. Make it even bigger. Let's go 30. Okay. So we've got a wall here. And we've got a. So this is our wall row. Am I going to do it in here? No, I'm not going to do it in here. I'm going to do test a wall with a door in. This is going to be a test. So we do it like this. So we're going to have a wall row and give that a seed. We're going to need one on the other side. We're going to need the door itself. We need to bung it all together. Let's replace this with test door. And yeah, so we can door in. Oh, door, interesting. You are rotated. Oh no, it's just not hooked up. Big door, yeah, that's fine. I'm going to merge these together, but we also need to cope with working out where the door is going, and we're going to do that with some splits. We are going to okay, let's for now, again, it's a bit of a hack. I'm going to say our door position. Let's do door offset. So that can be the center of the door. And if that's 0, that's not going to be any use. And then let's go with 50. So the center is at 0. That's going to be half out at the end of the wall, so we'll not show it. What we need to do in that situation is work out whether or not valid to do the split. Stuff it. We're just going to do it regardless. So we're going to the left of the door. We need door position -5 because the door's 10 wide. So we're going to subtract that. That'd be 5. That will be the amount we need to split off the left-hand side. Oh, we're doing it in Y. What's that? Yeah. So that's going to be our left, which if we now disconnect those for a minute. So that will be our left-hand side. And we're going to split off the door next. So we're going to, from whatever's left from that, we will need the door, which is going to be 10 here. That's our door. And then whatever's left from that will go on the right. Now we can position our door, and we will ignore it going out of the whack because that doesn't make any sense. So there we go. Ah, interesting. So we're going to need to set it back because a door is shared, I think, and it would look nicer if it didn't have this sticking out. But to set it back, we're going to need some filler. So I think we might make that part of the door logic. Let's open it a bit. Are we going to do that in here? Set back and fill. You can do that now. We've done an hour and a half. I might stop. Oh, we've done loads today, and we have got a door in a wall, which is a start. It's not quite in the right place. We're going to set it back because if it's two rooms next to each other, it will be shared, so it will need to be centered on the sort of join line, which is going to be back here somewhere. Or we could. I might just see what that looks like. Let's do that in here. So the door we're going to offset by -1 in Z, something like that. No, it's probably not as much as that. No, it's not. It's more like, let's do 0.5 minus 0.75. Yeah, let's go with that. Not quite right, but anyway, that's the sort of thing I was thinking. Oh, interesting. These black bits tend to be intended as non-visible parts, but they actually are visible. I'll have to have a look at the sample scenes and what that looks like. But yeah, we're going to need some of these pieces to fill in front, above and below, and then decide what we're going to do with these. Could either don't really want to recess it in there, but we could put something on top to cover it up. A pillar maybe. Something to play with, but we now have a wall with a door that is configurable. You can put the door where you like. Oh, and if we, in our test, if we bring that out, so that's set like that. We can also open and shut the door. Where do you want your door? How open do you want it? Yeah, so we'll tidy that up next time. The positioning, oh yeah, we're going to need some filler because of that. We're going to need a piece of pillar in there. Probably one of these corner pieces. I will check what they do in the actual tests. Otherwise, that looks good. Okay, so next time we'll tidy that up and we'll look at getting it into the actual room and how that's going to work. So, until then, let's call it a day. Thank you very much for coming. It's been lovely having you here. Whether you're on the live stream or whether you're watching on catch up, equally good. Please try and join me in the future. I'm going to investigate. I might try and do streaming at a different time, see if it's more accessible for people, particularly in different continents. If you've got ideas about what would work for you, then let me know on the. You can find me on social media. There's links in a minute, or you can you could comment on the catch-up videos, maybe something like that. All right, take care. I'll see you in the next stream.